And we're live.
Hey.
Hello, everybody. Thanks for coming back to the HVAC 2.0 show. Tonight we're going to be a little light until hopefully a few more people is going to be hopping in, but only have here Ken Dean with me, always bringing good company. Uh,
Welcome, Mr. and Mrs. America and all the ships at sea.
but yeah, we were talking just right before the show had started about interesting phone call you had.
Uh,
So,
yep, Ted and I were discussing. Oh, well, I had this, beg your pardon, there were two phone calls that I had today. This is the one from a customer who asked me if I was BPI certified. And my answer was no, I'm not. And I told him that of the BPI, of the folks that I know who used to have BPI certification, they found that it hadn't been that helpful to them because the majority of people don't know what it is or see any value in it. And the reason he asked is that the IRS has some deductions. I'm going to scroll up on my other screen. Energy efficient home improvement credit on the irs.gov website. But to get those credits, you have to have an energy audit performed by, scrolling down to the right place. The energy audit may qualify for a tax credit up to $150. It must include a written report and inspection that identifies the most significant and cost-effective energy efficiency improvements with respect to the home, including an estimate of the energy and cost savings with respect to such improvements, and be conducted and prepared by a home energy auditor, which is defined as someone who is certified. There's another link to those who have, well, let's see what will happen if I click on that one. Such certifications. ASHRAE, Association of Energy Engineers, BPI, Building Analyst, BPI Home Energy Professional, BPI Energy Code Compliance Specialist, BPI Energy Star Verifier, Building Science Institute. Oh, I'm sorry. Yeah, those last two were not BPI. They're BSI, Building Science, Zero Energy Ready Home Verifier, CalCerts, California Home Energy, and ResNet Home Energy Rater. And I did a search for BPI around me, and there's nobody that I know. Some people's names I see, but I've never heard of them, nor have I encountered anybody who
yeah.
used them.
On there, did it say anything as far as like the qualifications for I know it mentioned having to perform an energy audit and outline the biggest potential savings of energy, but is there like, does it, I mean, they have to like have a certain percent of energy reduction or something in order to get those incentives? Does it say anything like that?
I have not. I have not read the whole site. Residential under the heading residential energy property. Qualified property includes new central air conditioners, natural gas, propane, or oil water heaters, natural gas, propane, or fuel oil furnaces and hot water boilers, heat pumps and biomass stoves and boilers, subsidies, rebates, and it said public utility subsidies. How to claim. There's another form. Lots of, and as I told the fellow on the phone, most of these programs have so much paperwork for the contractor that it eats up all of our time. There's no profit in it for us. There's no incentive.
Yeah. Yeah. Well, and also, I mean, it's like, what are you doing this for to begin with? Like, did you just hear that you can get free work and you're going to save energy and, do all this great and wonderful stuff? I mean, what's the actual end goal? Because, I mean, we all know that, I mean, you take a halfway decent house, that say it's a 1-to-1 layer for
Mm-hmm.
infiltration. I mean, how much improvement can you make on a house like that? I mean, you're going to spend how much money and it's going to cost how much time for what? $10 a year savings.
Yeah.
Like what are we doing at that point?
All of these, I found another segment of this page. This applies to improvements in 2022 or earlier, qualified energy efficiency improvements, residential energy property expenses, home energy audits, maximum credit you can claim each year, $1,200 for energy property costs. Who qualifies? Located in the United States. Business use of home, qualified expenses, exterior door, envelope components, exterior doors, exterior windows and skylights, insulation and air sealing materials or systems that meet International Energy Conservation Code standards in effect at the start of the year, 2 years before installation. Yeah, there's so much to unpack in order to do this. If this were in a densely populated area and somebody had a dedicated staff person who could do all of these things, it might be worth it.
Yeah, and which even like what Ted's mentioning here, they'll give, very small credits to the contractor. And, I mean, it's the equivalent for when when manufacturers give a credit back to the contractor for labor. You do a warranty part and they're like, oh, we'll give you $30 in labor. And it's like, oh, that's great. I needed, $182 to break even. So I've only lost $150 an hour doing this work for you. I really appreciate that.
Yes.
The disincentives that stack up just get so harsh that, I mean, who's going to use it? Like, where's the actual utility of it?
It's sort of like taking the time to claim a warranty on a failed capacitor.
Yeah.
You're better off just throwing it away.
Yeah.
And eating the cost.
Yeah, so you can put back the same crappy capacitor that failed within a year to begin with. Yeah. That's it's basically it's just as nonsensical. Makes no sense whatsoever.
Yeah. So it's great that there is some attention being given to energy incentives, but so often when you dangle dollar signs in front of people, they become zombies in pursuing it to the neglect of the things that are really wrong with their house. Things that make them comfortable.
Well, I mean, how many times does it have to be done for people to kind of realize that, okay, the energy incentives at the consumer level just don't work. In order to put together a program, it's going to be so complex that it's going to deter most people away from it. And usually these programs, when they're put together, it's ridiculous anyways. So it's just going to promote poor outcomes. And so if anything, it's just dissuading people from good paths for good outcomes.
Yeah.
So you would think after I mean, how many utility programs have there been that's just failed miserably? Like, how many times do you have to create the same program and fail the exact same way multiple times before it's like, oh, maybe this doesn't work. Maybe we're wasting time and money here. But evidently not. Evidently, this is a very difficult thing to learn, and nobody is able to learn it.
Yeah. Let's see how long. 10 years ago, I will estimate, I had a customer call asking if we were on the gas utility list. Now we were registered as contractors, but we were not on their program. He hired a contractor from a community that's an hour and a half drive away. The two installers were there for 2 days. They spent the night at a motel. And when all was said and done, the customer had me come over in order to coordinate, to set up the thermostat for the dehumidification to go along with the blower settings. And after he was done, he said, I should have just had you do this to begin with, and never mind this ridiculous credit.
Yeah. Yep. And that's usually how that goes.
Yeah.
But
now, not that it's all complaints, because I will say that in 2010, which you probably weren't even involved in the trade then.
No, I wasn't.
There were rebates, which were pretty straightforward. And essentially what happened at the time was customers would essentially pay the price for 10 SEER equipment, and they received 13 SEER equipment. So it was a bonus for them. I described it as them paying for the Chevy Impala and getting the Cadillac at the
Yeah.
time.
Yeah.
And that one was relatively easy. It was a single page form. All we had to provide was a certification from the manufacturer, which they could then take to their accountant when they did taxes, and the government gave them the tax credit. So that was straightforward, easy to do.
Yeah. Yeah. Which, especially for pushing electrification and this, these energy programs. I mean, Nate's idea with moving the incentive at the manufacturer's level of just going, how about this? Stop making ACs.
Yep.
Only make heat pumps. Like something like that that's extremely simple and it's kind of a no-brainer to begin with. But, again, if you do that, not enough people can get kickbacks. People can't make, money off of a quote unquote moralistic incentive program.
It's
So
not
you just can't do
popular
it.
enough to get passed. Yeah.
Yeah. And so it's sometimes the straightforward is not what people want to have, even if it's the simplest and the best path.
Yes.
But which rolling into the next topic for tonight, we was going to be discussing load calculations, likely load range, and a few other things to that nature. Because it really seems like here lately, there's a lot of people making a lot of really good points in regards to the accuracy of manual J,
Or lack
potential,
thereof.
yeah, or potential issues, not issues with it, but rather things that really just get overlooked. There's this false sense of security with manual J in being that if you can just punch some numbers into a computer and it spits out a number, that number can't be wrong. You don't actually have to double check, anything. You could, if you've got 2x4 construction, we have R11 walls. So let's just punch that in. We're going to assume, infiltrations. Well, it's a 70s house, so it's definitely loose, right? Things like that. And so it's been a lot of people who have
Hey, Ronnie.
really seen. Oh, how's it going, Ronnie?
How's it going?
Pretty good.
Good.
But like
Sorry,
I said,
my time changed an hour here, and I was cooking, and it said 7 something on my stove, and I had to change the time on my stove.
And you were late to all your appointments today too.
No, that was because I was using my phone earlier, but literally I was cooking, and my wife's like, "Do they have a meeting tonight?" And I was like, "Yeah, but it's at 8," and she was like, "It's 8:30 almost." So,
all right. Well, I think you should keep her then.
yeah, she's definitely a keeper.
Well, did you get your clock fixed on your stove now, so that we don't have to worry about having you late now?
I even looked over at the microwave, and it was wrong too. So everything else automatically changes. I didn't even realize the time changed.
Yeah.
Yep. Unfortunately, so it can screw everything up for a week.
Yeah.
But yeah, in regards to the load calculations, like I was saying, I'm sure everybody's kind of seen the talks into the narrative of load calculations. I know Corbett Lunsford and a few other people really seem to have, really started harping on the idea that, hey, maybe your manual J's are not as accurate as you've been thinking they have been. And so
especially
I think
without a blower door.
Yes. Yeah. Well,
That
I think
the critical piece.
yeah,
Yes.
I think it really started with that. People started kind of going like, "Oh, wow, like if I don't know how leaky the house is, then that's a problem."
Any old assumption we put in will do.
Yeah. Yeah. Or the still, it's always hilarious to me when I see people making the argument of like, "Oh, well, you don't have to do a blower door test. You can just look and see. Like you can just look and see the air leakage because that's definitely how that works." But
It'll
I think
be extreme if you can see it.
yeah, if you can, you should not have to work a day in your life. You just walk through houses with people and just see the leaks. Um, but I mean, it really seems like it started with that. Like that was the entry point of like, okay, if we really want to have these load calculations to be accurate, we need the whole picture. We need to actually gather the data that's needed so we don't get into this dilemma of garbage in, garbage out. And
Yeah.
so, we want to talk about that. Well, you can't say, well, if Manual J is perfect, it's garbage in, garbage out, and then turn around and say that you don't need to do a blower door because that you're putting garbage in, and your best bet is that you just guessed correctly. And so it seems like that was like the starting point. But now it seems like people starting to come around to the idea that, hey, Manual J kind of, depending on how it's being like in terms of the fudge factor, like different softwares can kind of sway the fudge factors in different ways. Cool Calc seems to be one of them that leans on the oversizing side. They lean those fudge factors on the high end, and so it's becoming a thing of where just because it's ACCA approved Manual J load calculation doesn't necessarily mean that it's going to be very accurate, especially on the heating side of your load. There's actually a very good chance that your heating side is going to be extremely disproportional to what it actually is.
Yeah,
And
at least 30% oversized usually.
oh yeah, that's probably true. I mean, sounds like a good number because I know in running my own loads using which I've used several different ones, but and I like Cool Calc. I still use it on occasion, but for me, fortunately, I'll only look at cooling loads anyways, and that's how I really base everything off of because I know my heating's going to be pretty close, even if it's a leaky house, for the most part. But um, when I started really looking at those load calculations, trying other softwares like Quick Model and tracking run times, it started to become very obvious that, oh, hey, you know, Manual J saying I have a 60,000 BTU load, but I have a 14 SEER 3-ton heat pump that's maintaining down to 20 degrees. So it's like, somewhere these numbers aren't adding up because that 3-ton cannot do 60K of heating, not without strip heat. So it's like, that kind of for me started the path of going, okay, what's up here? Like, what can I sway and change? And so I personally started just when I was checking these loads, I started going in and changing up the data and just going, okay, let's assume the house is tighter than what it is. What if we assume the house has better insulation than what it is? And it's like, you have to really lie about what the house is to get the heating load anywhere close to what it actually
Yeah,
was.
I find
But
myself doing that in some situations to try to get the heating load right.
yeah,
But again, you're probably right. You probably don't need to worry about it as much as the cooling load. If you get the cooling load right, then the heating's probably fine, unless you just have a really messed up house.
yeah. I mean, for probably climate zone at least 4 and below, potentially 5 and below. If you tend to size towards heating anyways, so if you're doing a heat pump, size towards cooling, or if you are doing AC gas or a dual fuel, size your AC according to your cooling load, and then just get the smallest furnace you can get. It seems to be, if you're going that route, that tends to be probably the safest route of avoiding that overshooting scenario. What do y'all
In
think about
most
that?
cases, it'll work. In some situations, I've had like a house that one of our sales guys downsized the outdoor unit to a 2-ton, and then the 2-ton didn't keep up. So I went
Mm.
back out and I said, "Well, what did you have in the house before?" And he's like, "Well, I had a 3-ton and it did fine." And this is like a 1,450 square foot house,
Oh,
but
dang.
it's a 130-year-old house. He said it's insulated pretty decent. He's like, "But I don't think they sealed it up very well when they did it."
Mm.
So, it was a 5-speed, by the way, heat pump.
Oh,
Okay.
dang.
Yep.
With a gas furnace, MN7, 60K MN7. So the MN7's capable of doing, a 2 or a 3-ton. So I just had them change the coil in the outdoor unit. And then we waited till winter time. And then when we got that really cold snap in January where it was 0, that 60K did not keep his house 70 degrees. It couldn't get it above 62.
Mm.
So we had to go in and put an 80 in there. And
Yeah.
then after we put the 80 in there, then he started having duct pressure issues and faults and all this other stuff. And he's like, well, what are y'all going to do about this? So I'm not going to do anything about it, because technically we put the right equipment in originally. The problem is your house. There's problems with your house, and now we've made this furnace match your leaky house, so the ductwork's on you.
What
So
was that?
that's
Was that one that someone else had done, and then you just kind of had to come play
yeah.
cleanup crew on?
Well, yeah, that's exactly. I was the garbage man, so I went
Yeah.
in there and I cleaned it up and asked him what. I just asked him what worked before, And if it's a 5-speed and a 2-ton's not working, then obviously I got to do a 3-ton. And if a 3-ton worked before, the odds the 3-ton's going to work again.
Yeah.
So he seems to be mostly happy, except that he's getting these faults on his thermostat now, that he's having, issues with furnace overheating and doing stuff like that. But so we had to turn the airflow way up and
Was it
hope for the
a straight
best.
AC or a hybrid?
It's a hybrid with an MN7, like a modulating gas furnace. But when that furnace fired and was running in high, it was like throwing like faults and stuff. So
Yeah. Which the good thing, with a small house like that that's requiring that much, good and well, there's probably some uh, depressurization that's happening
the
and a lot
returns
of
are
leaks.
the main problems. His returns on the outside walls and the wall cavity returns,
Oh, wow.
Okay. So it's
and
pulling
that's
in
pulling an outside air. He's getting plenty of fresh air,
yeah.
and I told him, I said, this is the problem. We really need to relocate all these returns, seal these up, and you would be fine. And he's like, I'm not putting no money in it. It worked before. I said, cool, we'll put a bigger furnace in.
Yeah.
And that's what we did. And that's our guarantee says we'll make it right if we go changing the size and it doesn't work. But in any situation, that 60 should be able to keep that 1,500 square foot house.
Oh yeah, absolutely.
All day long. It's oversized in most cases, and a lot of times we turn them down, those mod furnaces, because unfortunately it's the smallest mod furnace that the Carrier Supply House stocks. So a lot of times we'll turn them way down to where they don't ever run above 45,000 BTUs when they're maxed out. But
Yeah.
I am currently working on a job that is they gutted the entire house. It's like studs, and it's a 1,875 square foot home, and he's going to make it 5,144 square feet.
Oh dang.
So
he's building a house to go. He building a house out
he's
around
doing
his
it this
house.
way to get permitting through, because where this house is, they're not going to let him build another house. And it's this guy owns a church. He found a 5-acre lot in the city, and he's building the house around the house, and they're going to tear like the old roof out, and they're vaulting the ceilings and doing all this stuff. And I know the guy personally, not like super good, but like as an acquaintance or whatever. And he's telling me he's going to spray foam the whole house. Like the whole house is getting spray foam, attic, the walls, everything. It's getting foamed up. So I've done a few different loads on the house because I can't pull a blower door number yet.
Yeah.
And I'm giving him estimates or proposals based on really bad job or a really good job of air sealing, because I don't see why they couldn't get that house down to 1,000 to 2,000 if they did a really good job sealing it.
Oh yeah, if they're spray foaming, especially. Or is it they go in open cell or closed cell?
So I think that's going to be a little of both. I think they're going to use some open and some, I don't know exactly yet, because he hadn't met with the insulation guy yet. So what I told him I would do is I'd build him a few different loads. I'd give him proposals, and then then I'm adding some money in for me to come in and test a few times. So I'm going to come in and test the home a few different times and see how good they did before they close the house all the way up, because he's doing the roof deck and everything. Like he's wanting all that space for like storage and part of the addition is they're building on this huge garage like triple bay garage, and then there's going to be bedrooms above that garage. And you
Oh
know how
boy.
we're talking about like a whole part of a house that's going to be above a garage, like 2,000 square feet.
Mm-hmm.
And we're going to put a dedicated system for that space.
That's
So-
good.
Yes.
It's going to take care of that, and then it come out with them doing a bad job at like 1,100 square foot a ton is where I'm at with a bad job. And then obviously we can get it down a little bit from there. And he's wanting to do fresh air on the house. He originally said ERVs, but I think I got him talked into positive ventilators instead.
Mm-hmm.
And we're going to do 2 of those, one on each system. And then the way he wants to do the downstairs is a little tricky. So I don't really want to zone it, but I may have to make it, because he's wanting everything within 2 degrees is what his specification is. So I may have to zone that space, but it'll be a multi-speed heat. It's going to be all electric too. He was talking about doing hybrid propane systems, and I kind of nixed that too. So he's putting 2 200 amp panels in this house. There's no reason to have propane gas furnaces with heat pumps.
Okay. What
And
does he have an idea on what type of equipment he's looking at?
he's wanting multi-speed inverter driven equipment after watching videos and talking to me.
But he's not decided on either a green speed or the 5-stage.
He hasn't, no. And it's going to be probably 3-4 months before the house, maybe even longer before it's ready for equipment.
Yeah.
So,
Well, I mean, if he's wanting to get within 2 to 3 degrees, I mean, he shouldn't be batting an eye at green speeds at that point.
we've already had all these talks, and he said money's
sure
really not an option, or that's not a big deal for this guy. He's got a ton of money. He just said he's going to live in this house the rest of his life, and he wants it done right. And he's willing to spend the money. And I told this guy, I said, you will find somebody that'll do this job cheaper than me. That they're not going to use the equipment we're going to use, and they're not going to, go through all the trouble and all the design. And I'm going to be here, like I'm putting money in it to where I can be at the job and multiple times and all this good stuff. So,
Not just handing it off to somebody.
I don't do that anyway in most cases. Anytime it's more than just equipment replacement, I'm going out and checking. I even help the guys do work sometimes, which they think's crazy because none of the sales dudes, like, I'll crawl under a house and fix some ductwork while they're putting equipment in and stuff, and they think that's crazy that I do that. And
yeah, I was about to say, I didn't know sales guys can do that.
Yep.
yeah,
You got to remember. You got to remember the little people.
That's right. And I'll bring them lunch and stuff too. I had a couple install, or one specifically that wouldn't even speak to me because he didn't really know me. He don't like any of the sales dudes. And now he and I have conversations when I'm at jobs, helping them do stuff. So, because he sees I'm not too good to help them or whatever. Some of the jobs that sell suck, and that's part of the reason he probably like, well, he doesn't know what it takes to do these. That's why he sells them this way. And but I do. That's why I sell them that way, because I do know what it takes to do them. But it's been a pretty slow month though thus far. I don't know about you guys, but
I'm retired. It's all slow.
Yeah.
So I watch Facebook and things of that sort. Yeah, Tanner and I were talking about so I'm looking at my other screen now. HVAC Grapevine had Russ King as their guest, and Russ has started DIY load counts, where a customer can download Cubicasa, send Russ the floor plan, and he charges a fee. I haven't looked into what that is, but he will then do Quick Model 3D and send it back to the customer. So the customer can then tell contractors who are coming in, I've got my load count. This is what I want.
Yeah. So
And
so that way they can fight with a contractor when they're going, okay, I want a 2-ton heat pump, and they're like, no, you're getting a 4-ton AC with a 100,000 BTU furnace.
yeah. Well, there have been cases online where customers have said, I can't find anybody who will do it to my spec. So, and Russ said he even provides, let's see, what do they call that file? That's not an FTN file, whatever their QuickBooks file is. If the
Oh, I
contract,
think it's a JSON.
yes, if the contractor has Quick Model, they can
Yeah.
load that file and fiddle with it themselves and prove to themselves that it is right. But one of the thing that struck me most is Russ said, with load calcs, it doesn't matter if you've got, you can try playing with it. If you have low E windows entered as what's in the house, and in fact you've got single pane aluminum frame windows, the difference that it makes barely matters. The only
Yep.
thing that really matters is infiltration,
Mm-hmm.
and you can go wildly wrong with the wrong infiltration number.
Yep.
So
And
that's what we're finding. That
yeah.
we've seen others online, Corbett Lunsford, Ed Janowak, and of course HVAC Grapevine. I think has Chris from TEC, and they're all coming to the conclusion that without this input, it's impossible to get an accurate an accurate result from your load calculation.
Yeah. I mean, somebody should have made a meme about that a while back. But anyways, we'll move on to the next part.
Okay.
Which this really ties into something that we put together of just kind of really tying this all in as to, like, I guess how some of us here kind of think about this. Because I mean, really, when it comes down to like coming to an accurate, like, of sizing equipment, again, let's be real. At the end of the day, when it comes to doing load calculations, the whole point is you're trying to pick what size equipment. That's the goal at the end of the day. And so there are several ways you can go about that. And the question really becomes of, when is it good enough? And at what point do you draw the line of it being too much versus it being not enough?
Mm-hmm.
And so, and if somebody here disagrees with this, I would like to see, uh, like, where do you think this might be wrong? Because I kind of slapped this together. It's not super scientific, just kind of from what I've kind of been noticing over the past several years of doing this. Of like the first layer of this is it's just guesswork. That's where you're getting your chuck in the trucks going, hey, we're going to get you 400 square feet per ton, and you'll be great and wonderful and good to go. As we all know, that can
How many
deviate.
does it take to cover the house?
Yes. I mean, all the same thing. Like,
Yeah.
at the end of the day, it's just guesswork. It's a wild guess, and you might guess right, or you might guess just horrifically wrong. So it's wildly inaccurate. Well, the next step that's slightly better than that is manual J by itself. Sure, we're going to get some things more narrowly tightened in, and we're going to be a little bit right, but guess what? We're still going to fluctuate by probably 2 tons on either side. So it's like, okay, we can be a 2-ton, or we could be a 4-ton. Without blower door, we really don't know. Or without a lot of things, we really don't know. The next level of, if you really want to get that tightened in, is going to be a manual J assisted with blower door. So now we know what the infiltration is. We know what the air leakage is, tied in with that load calculation. So then we can get fairly accurate, but there's still a problem.
Mm-hmm.
At the end of the day, houses are operated by people, and sometimes people do weird things, and sometimes weird things happen within the house that makes outside parameters that you don't expect to influence this. Such as, an example would be, everybody's known the scenario of, you have, say it's an older person, they've lived in the house for a long time, You do your load calculation based on your design temps, and lo and behold, they keep their set point and cooling at 80 degrees.
And heating at 80
Yes.
degrees.
Yes. So it's like, okay, that affects what the sizing of equipment is.
Yeah.
If you're trying to size it to this part, if this person's buying something from you and they want equipment that's going to do what it is that they want, I mean, that's
You've got
something
to
you have to take in, you have to take that in consideration. Now, does that mean, let's say if they're like, I want to keep it at 60 degrees all the time, does that mean that you size the equipment so it can maintain 60 degrees just without a bad night? No. Like, you're going to have to be like, hey, we can do that, but here are the risks. Here's what we can run into. Are you okay with this? Like, you have to have that discussion, but at the end of the day, it still influences how the thing works. So if we're trying to eliminate people calling us and being mad at us, we got to have these conversations up front, like the story that you had, Ronnie, of how they threw a system in and they had to pull it out, went back with the same size system that it was before, and then it's like, well, come to find out the house is really screwed up. A lot of those things, if that original sales guy had have had the conversation that Ronnie would have had with him, going, hey, here's the risk that we're looking at. We can size this, we can go this route, or we could look at a comfort consult and know for sure. You're kind of laying these what to expects out of, if we do this and things like this happen, here's our next step. Being, if we downsize and it doesn't keep up, well, then the next step is to do a comfort consult and to see why our house is so out of whack, and then work to bringing that down. So it's presetting these expectations. If you don't have those expectations preset, then that's where people start to get mad. Now, after the manual J with blower door, we're still within, what, a ton on either side that we can fluctuate based on other factors outside of the load calculation and leakage. The comfort consult that's where you start sprinkling in some of these other factors that really narrow that in. So then we're not just doing our manual J with blower door, we're also looking at energy use. We're also seeing what their set points are. We're seeing what the static pressure of the duct system is, because, if they're wanting to go back with the same size, but our ductwork's too small, that's a problem. Like, if we've got 3 tons of ductwork on a 4-ton system, guess what? We're doing 3 tons of cooling. And also house use. That's another thing that people don't think about is okay, do you open up your windows during the springtime all day and then close them at night? Well, guess what? Electric reheat's a great thing, but if you do that and you try to dehumidify down to 50% overnight like that, you're going to use a lot of energy. And so that's another factor that's going to play into this. You got to have that discussion of, hey, do we really have to be opening up our windows all the time? Why are we doing that? Is there something that we're trying to achieve that we can do it elsewhere without having to just open up windows? We're really catching all of these other little things that can influence why the equipment we put in is not going to perform as expected. We're really trying to collect all that.
Tanner, let me suggest that over at the right hand of this screen, what all of these things are funneling over to is, and I wish I could remember where I read this expression recently. The point of the load calculation is to size the equipment so that there is no excess capacity.
Yes.
I think that's, if we use that expression with homeowners, it helps them see more of why we don't want to oversize.
Yes.
So if this were an arrow, and I'm trying to do the hand gestures to indicate what's on your diminishing target over your aim is to have no excess capacity. So you'll have to know, as you've said, what is their expectation for the capacity. So we need to know all of those items under the comfort consult.
Yes. And in which each step as we go down per bar graph, all we're doing is we're reducing the tolerance of accuracy, or the margin of accuracy. We have a margin of error at each level, and every single, like, none of them are dead on perfect. Like, even with a comfort consult, we're not going to be getting it exactly, but we're getting it within a half a ton plus or minus. And guess what? That's close enough.
And
Like,
let's remember that throughout the seasons, the load will vary.
Yes.
So we're only talking about design condition 2% of the year.
Yes. And
And
so,
again, that language helps the customer to understand why we are trying to avoid excess capacity.
yes. Well, it's not just that, but it's also just meeting the expectations and
Perfect.
understanding that. It's like, because with this chart is we're just narrowing in on accuracy of sizing. Like, that's what this is meant to illustrate. And I mean, we can go even further to the CPP, the comprehensive planning process, and we can add additional points to this, such as a full energy audit. We can start looking at a localized leakage. So, like, if you do a room by room load, because if you do a load calculation of a house, say you do a whole house, a block load,
Yeah.
well, that's not looking at how the leakage is distributed. If most of your leakage is coming from, a master bedroom above a 3-bay garage, like what Ronnie is about to be dealing with, and that's where the most of the leakage is coming from, well, guess what? The load in that particular zone is going to be far greater and disproportional than the rest of the house. So even with us getting all these things within the comfort consult, there's still things that could potentially be overlooked because there's additional things to be tested. It's just the question becomes, is are we getting it within reason to where we can size the equipment appropriately, and then discerning whether or not there needs to be shell work and to move on to the next stage. And so we do have the CPP if it has to go there. It's very minimal. Like, there, usually if you catch everything else, you're typically good. And if not, you're setting yourself up to where you can correct those problems and you don't have to go back and resize the equipment.
I'd be inclined, Tanner, to say that the things that I'm seeing on the right hand of the chart, starting with manual J with blower door, you could make that one smaller. Chances are we're going to get, for the majority of houses, unless it's a basket case, we're going to get to the comfort range for the customer.
Which I would argue with that, even if you only do manual J and you're only getting the blower door, there's still factors that could be overlooked that could cause it to swing.
Provided the customer has voiced their concerns to you.
Yeah, well, that's where I guess I'm kind of using this to emphasize the importance of, like, the interview portion. So, like, when we're talking about the house needs, talking about the external static, the set points, and energy use, we're kind of looking at a lot of those things. And so if you don't look at those things, that's where the margin of error comes from. And so you can't just go in and only do a load calculation and only do the blower door. I mean, you can, and you're going to be a lot more accurate than someone that's doing guesswork, but you can still, if you guess, on the very low end, but something's going on that's, causing it to be more on the high end, you can still be off by a ton. You can go put in a 2-ton where a house actually needed a 3 because there was things overlooked.
The house Ron had.
Yes.
Yeah,
And exactly. And so there's these things like that are really needed. So I guess where we've all kind of came to is it comes to where do you draw the line of at what point do we go, okay, if we're going to go down this route of doing load calculations and design, what is the minimum, and what are we just going to go, okay, I'm like, obviously we're going to do some form of calculation. We're not going to guess. So we know the first block is out of the question. We're not doing that. And when I say guesswork and in terms of this, I'm referring to you're going out and you're telling the homeowner what size they need, if that's the route we're going. So, I feel like everybody here, we've kind of come to the conclusion that, okay, we're drawing the line in between, right after doing a manual J with blower door, because it's like, if we're dragging the blower door out and we're doing this load calculation, you might as well get energy use. You might as well ask them a couple of questions, and you might as well go ahead and check static pressure.
And what's the customer willing to pay for?
Yes.
Which
and
is,
so,
yeah.
yeah.
We're yeah.
I'm either at manual J or comfort console. I don't do manual J plus blower door. That's never an option for me.
Yeah, and which I mean, that is true. I should do a caveat with that. In a situation of, let's say, a retrofit, we're talking pre-existing house, we're talking with dealing with a homeowner. There are scenarios where, like, okay, it's a new construction or it's an add-on, and you're dealing with maybe it's a builder, a GC, or the homeowner's being the GC. And
The
so,
one-off or
yeah,
whatever.
so you only have manual J only as an option.
Yeah.
Sometimes
Well,
but here's the
that's what
thing,
I
the
have right
accuracy
now.
doesn't change.
But I put some generic blower door numbers in too. So I ranged it between 1,000 and 3,000. So I guess that load I just did would be manual J with blower door because we don't have energy use because the guys never lived in the house.
Yes. And see, and what's happening is with this,
It's not common though.
yeah, so like if we're doing the comfort consult, and like really what this graph is showing is like there is a margin of accuracy. And what you're doing when you can only do the manual J, you're being very transparent with the fact that, hey, there's a margin of accuracy with only a manual J. Like I'm going to put in some of these blower door numbers, but I'm making some assumptions here. And if I assume you build a house in this way, here's what we're looking at. If you build the house a little bit leakier, here's what we're looking at, so on and so forth. And then also we're making assumptions on the level of, okay, I'm going to assume you're going to have normal set points. If you're keeping it 65 or if you're keeping it 80 degrees, like that's abnormal. So if you do abnormal things, we should expect abnormal results. But again, we're portraying this margin of error within the different methods by doing these things. So it still holds true. And so, like I said, the caveat is when drawing the line is, it's case by case, but for the typical topic of conversation with, say, retrofits and such, this is the comfort consult is really if we're doing anything at all, it's this or nothing. Because anything less than that, you're going to be very dissatisfied because I'm going to have to make assumptions and I'm going to make you have to make assumptions and people could get mad.
Yeah.
With 5,000 square feet, I think I'd be okay plus or minus a ton with the house that size, but still, I get what you mean, especially with multi-speed equipment.
Yeah, and kind of with what you'll be doing, because I mean, if you size small, and it'll kind of tie in with likely load range of what we'll talk about at the end. It really all fits into where if you can make good assumptions on things, then if you do miss the mark, then you can do other things to bring the house to the equipment rather than have to change the equipment again. And so it's a way of looking at it differently. Because so like if you do, say we perform a comfort consult or a CPP, say we do a full energy audit and everything, we're going to come to a load that's going to be a specific number. It's okay, this load came to 34,000 at your current leakage or for heating and 32,000 for cooling. Like we're coming to an exact number. If you have all of the available data, we can do this. We can go, hey, your house, we're looking at a load of 34,000 BTUs. And we can do that with like I said, knowing everything. If we don't know some of those things, it gets a lot riskier with trying to make these harsh assumptions with our exact number. Wouldn't everyone agree? If you could only do a load calc only, that it kind of, you're having to make assumptions, and so it gets a little unsettling with, okay, who's going to be making these assumptions? Who's going to be left holding the responsibility bag?
So Tanner, do you have the one of the charts for the likely load range?
Yes, I do. I've got that next.
Because that's what we need for the alternative. Instead of if the customer isn't so concerned that they want to spend the money for a blower door test and a full manual J and disaggregating heating bill, utility bills, and a complete home performance test, likely load range.
Yes. And that'll be, we're going to hop to the next. I was wanting to hit this question real quick to see what this was for someone.
Yeah.
if your question is going from, let me go back. If you're talking a difference in going manual J only to manual J with blower door, could it make a 1 ton difference in sizing? Absolutely.
Mhm.
Actually, it could be greater than 1 ton by easily.
Just on
Depending on,
average, it would be 1 ton.
yeah, on dependent on climate zone, of course. If you're in,
Yeah.
Florida and you only deal with brand new slab houses that's foamed, okay, sure, you can make some more accurate assumptions on things because it's pretty consistent. If you're in a climate zone 5, 6, 7, where you're dealing with a lot of old houses, and you have a 2,000 square foot house that could be 1,000 blower door number all the way up to a 10,000 blower door number, yeah, you're swinging pretty heavy on that heating side. Um,
Hmm.
so I guess the answer is
Yeah.
yes.
And we may want to say um, Tanner's in Alabama, so he's a cooling dominated climate. I'm in
Yes.
Ohio. Ronnie's in
Louisville.
Louisville. Okay, you're not in Indianapolis, Louisville. So yeah, we are sort of split. But we're
Yes.
finding that the first thing, if it comes down to trying to get the customer more comfortable, depending on their budget, tighten the darn envelope first. If they're not going that route and they just want to deal with the house as it is, and they've come to us to help them get comfortable, we need to know some things. We cannot make assumptions on our inputs for a blower door test, for a load calculation, and hit the target. We need to know more.
Yep. And to re-hit on the point that Ken, I think, was about to start to get into, uh, if we are going to make the design, we need to do like if we're going to do it, let's do it correctly. Let's gather the information needed. Let's have the discussions needed. Uh, if we're not interested, if the homeowner's not interested in paying the money to have that done, and we're going to have to make these assumptions, and this is where Ken was starting to lead into on the next thing, is likely load range. This is if we can't do anything below man J only and lower, like if we can only do man J only, or even I would even argue that man J with blower door only, if that's all we're doing, which odds are nobody's really doing that. You're going to have the discussion, you're going to be doing other things, and then the question is, are we doing this for free? Hopefully not.
Mhm.
So it's that's so the question is really, okay, man J only or less. If we're doing that, the more accurate way of depicting that is not to show somebody a load calculation that could be plus or minus, if we're plus or minus 2 tons. Before we do that, likely load range. Let's be transparent with
And
what it
partnership,
is that's actually happening.
get them to share this decision.
Yes. No, we're not sharing the decision. We're
Well,
putting it on them.
we are sharing the information and letting them make the choice.
Yes, because the reason this is more transparent is when you've tested enough houses and you've done enough load calculations, one of the things that everyone seems to have come to the conclusion to is we figured out that, okay, a house of a certain size built a certain way tends to fall within a range of what kind of load this house is going to have. There's good houses that fall within the green range. There's okay houses that fall within the yellow range, and there's bad houses that fall within the red range. And this makes up at least 90%, if not more, of houses. This is excluding the passive, super, efficient homes, and it's excluding the absolute basket cases. Um, it, Portraying if you're doing things for free, before we're doing a basic manual J, which is going to be giving a false sense of confidence in what size you actually need, this is the most transparent way of actually articulating to the homeowner, here's what your house could need. And if we're not doing a comfort consult to figure this out, here's what we're looking at. What kind of house do you have? And so then the knee-jerk argument I'd imagine a lot of people having is, oh, so we're just going to guess at this, and then what happens if we guess? And I would say, how about let's look at this in a different way. if we're going at this from a position of we're going to do design before we do the work and then implement said design so that way we hit the nail on the head and we don't have to worry about it. I mean, that's a good way of doing it. That's what the comfort consult's meant to do. But what happens if somebody doesn't want to pay for the comfort consult? This is a way of kind of presetting some of this up to go, hey, if we size in the green, it is the less risky route. It doesn't mean we're not going to have to come back and do something again, but it's the less risky that enables us to not have to change the equipment again. So, for instance, let's say we guess. We say, okay, this likely load range on cooling is on the bottom end is a 2 ton to 2.5 ton system. Okay, you go 2 ton. You put in this unit. Well, guess what? It doesn't keep up. Just like Ronnie's situation, they downsize the unit. It doesn't keep up. Oh no, what do we do? Well, if we're being transparent up front, it's, hey, this is something that could happen. We could put in this system and it might not keep up. And when it doesn't keep up, that's when we move to the comfort consult and then address it if we have to. And what we can do then is then take the house, tighten that, if old, very leaky house, tighten it up, move those returns that's on the exterior walls, pulling in a ton of fresh air, adjust that, make corrections to bring the house to the size of the equipment. So that way, each step of the way, we're making improvements. We're not going backwards in any regard. We're going, okay, we're putting in equipment that should be for a good house. And then if the house isn't good, we then make improvements to the house or the duct system to bring it to where the equipment is, to prevent situations of having to change equipment again. Because, I mean, we all know what happens if you oversize, because a house that's in the red, they're not going to be comfortable anyways. If that's a legitimate problem, then
typically you can look at the duct system they have in place, and if it looks like they have about the right amount of ductwork for each room, you size that ductwork, and if you have 2 tons worth of ductwork, then you're not really carrying 3 or 4 ton worth of cooling in that home anyway. You never have.
Right.
Yeah, and that will that could make a good a good argument for choice of equipment. If you only have enough ductwork for 2 tons, that's a good, say this is our likely load range we're looking at for that particular house. That's a really good assessment to go, hey, if we're going to make assumptions, it's not a bad assumption for us to go with a 2 ton. So that way, at least it's matching the ductwork. At least the system's going to function correctly. At least we're not going to have those problems. And then in worst case scenario, when it gets, a week out of the year, it's not going to maintain temp. So that's worst case scenario. Now, if that's a legitimate problem, then we have the option of fixing the house. If the homeowner has some DIY capabilities, they can do it themselves. They can get some caulk, some foam, and do it themselves if they don't have the money. Like there's options available.
Or if they want to go in the yellow, we can put more ductwork in the house.
Oh yeah.
That's also an option too.
Yeah. There's so many more options when you size aggressively that way, to where you can always come back because there's so many levers when it comes to achieving comfort, and as long as we're pulling levers in the right direction, we're going to be making improvements. Because the alternative thought for this is going to be, how about this? We do load calculations for everything. We size not aggressively. We size too big. And then what? Now we have an oversized unit that's still uncomfortable. And then what do we have to do? Well, now we still have a screwed up house. We still have an oversized system. So now we've got to redo everything.
Yeah.
And so it's this
bigger
flip.
problem.
Yeah, it's this flip of thought of going, okay, if someone doesn't want to pay for the comfort consult, they don't want to pay for the blower door, well, can we move this step after an install? Can we do blower door testing and the comfort consult after we go ahead and put equipment in? Well, if you've done enough comfort consults, and you don't have to do a ton of comfort consults to get to this point, use all of us that's done it and kind of come to this conclusion, like use this information to come to it yourself and go, hey, we figured out that a 2,000 square foot house tends to fall within this range of systems or system sizes, And if we're willing
Mm-hmm.
to size aggressively, then just understand that, hey, here's the pros and cons. Because if we're not willing to pay money for a comfort consult, we're trading upfront cost for risk. That's what the homeowner's doing.
Mm-hmm.
That's what they're agreeing to. And so let's be clear with that and go, hey, if we're willing to trade upfront costs for risk, well then let's understand the risk. If we size on this side, here's what we run into if this is wrong, and here's what we can do about it. If we stay the same size or size large, well, here's the cons of that, and just lay it out and go, hey, here's what we're looking at. What do you want to do? What sounds the most or the which one can be the most settling if things go wrong?
Yeah.
And
Of course, we've been talking about things from the standpoint of the contractor. In many cases, we know very well what the right process would be, but we're not there to rescue anybody at our own cost. Our expertise needs to be paid for. So
yes,
our our motto is guide, not hero. Tanner, can you share my screen? Can you set me up to share my screen? I've got my
yeah, let me see.
where did I? Oh, there it is. And then I've got to do something to share my screen. Let's see. I've got to do that one. I've got to go into Slack, into present. That's what I have to do. Share screen. Okay, I'm going to do that. No, that's not the one. There we go. Is my picture up?
I'm not seeing anything.
Oh, well, Tanner, if you've got it, go to Slack. Did you see the meme I posted?
In which channel?
Funny.
Okay, I'll grab it. Yes. Let me get the.
I have not seen this movie. I just want to put that out right now.
Let me see if I can.
Oh, okay. Well, maybe this is. Nope, that's not the one.
This is it.
Okay.
Yes. Yeah, which we'll use this meme as a backdrop to kind of re-hit on this because there's a lot of truth to it. Here's the big pitfall and the problem with, you know, it's it's so common, especially as people start doing testing. It's real easy to fall into this where you want to go in and you want to do free consulting. You want to start telling people because I mean, you fixed houses, you know how to fix houses, and you're talking to the homeowner and they're like, "Oh, I have problems A, B, and C." And in your mind, you're going, "Oh, wow, I know exactly how to fix that. Now let me try to tell you what you should do." And there's this interesting dynamic of when someone has not paid you money to be a consultant, they're not exactly accepting to your free consulting. uh, a lot of the times it's just kind of going in one ear and going out the other. And so what that ends up being is a lot of time and effort wasted that leaves you just holding the bag with either, you didn't, someone else come in and sold something up under you, or you did work and now you're held responsible for everything because you told them what to do. Meanwhile, you didn't actually test everything that you should have because you were irresponsible with taking responsibility. Um, a lot of things like that. And so it really kind of comes down to, hey, like let's let's break down what it is that we're going to offer. Free quote or paid consulting. What do those two options look like? Or if you have some third option for wild cases of, new construction for say, like what Ronnie is currently dealing with. Um, but at the end of the day, you can't go out and just start giving away free information left and right because nobody's going to care. I mean, you might have
Well,
what,
if you're
1 or 2 out of
giving out
10.
information for free, they don't look at you like you're a specialist anyway. Whereas if they're paying for that information, um,
Yes.
they respect your opinion.
Valuing yourself.
Yeah,
Yes.
yeah.
Yeah, well, because, you know, you give somebody something for free, they don't value it. They don't take care of it. I mean, you take a kid, you give him a toy and say, "Hey, here's your brand new toy. I'm giving this to you. It's an expensive toy." He's going to go have it in the dirt, dragging it through the mud. He's going to have it broke within a day. He doesn't care. You fast forward several years and you let him buy his own thing. He's going to take care of it in a very different way. The value is different because he gave money for it. He gave something that was of value for something that he has now, and he values it more because of that. Your consulting is the same way. When they pay for your consulting, they're going to value it more. They're not going to pay you $500 to come out and do some testing and talk them through some stuff and them just ignore you. I mean, which I guess I should never say never. It's possible, but the likelihood of that is a lot lower than usual. But now you go to somebody's house on a free quote and you start telling them what they should and shouldn't do and all these additional upgrades, this and that, and blah, blah, blah. They're not paying attention. They don't value what it is that you're trying to give them. And so at the end of the day, and really, if you're giving it away for free, you don't value it either. So if you don't value your own time, why should they value your time? So
Yeah, we're not going begging for jobs. We
yes,
shouldn't.
yes. And so at the end of the day, it's okay, are you going to pay me for me to tell you what size system you need? Oh, yes. Okay, well, we have a path for that. It's called a comfort consult. Here you go. Um, you don't want to pay for that. Okay, hey, that's perfectly fine. Most people don't want to do that, and most people don't really need to. So I can help you define what your specification is going to be. And I can do it by, hey, let's go through a couple of questions. I can offer static pressure testing for $30. Can we check that for you? Okay, you can. Bam, we check that. Oh, we're on the borderline. We're at a 0.6. Here's your likely load range based on your size of house within this area of this construction type. Here's what we're looking at. What do you think you should go with? And they're like, oh, well, what if I size in this green? What happens then? Oh, well, that's going to be our safest route. If you size somewhere within this range, the potential pitfall is that it is too small. We undersize your system and it doesn't keep up during extremely hot times and extremely cold times. And of course, they're going to be like, oh, well, that sounds terrible. What happens then? Well, the good news is we always have the option for fixing the house. Now, if we do the opposite and we size in the red and we get that wrong, our only option is to come back and replace this equipment again. But either way, we would have to do the comfort consult to do that to begin with, but you may or may not need it. So we're presenting this information in a way that is being very transparent with, hey, we don't know what size you need. And unless you pay me to do consulting and to do testing and to figure it out, I cannot in good faith give you these recommendations to tell you what size you need. All I can do is give you a range of here's where your house is going to fall. It's somewhere between these 2 points. I can guarantee it with 90% accuracy.
Here's what I offer for the free quote.
Yes.
I offer these ranges. If you would
Yes.
like to be more precise, that will require more time investment on my part. Here are my fees.
Yes. And
Yeah.
so,
And what do people go for? If Reedy were here, he'd say they're choosing the green. They're
yes.
choosing better equipment. They're choosing the features of better equipment with filtration and air mixing, dehumidification, because they now understand it better. That's been my experience with comfort consults, and even with educating customers on areas on which they are willing to be educated. If they're not willing to be educated,
Oh, yeah.
we need to fall back on this range and let them make their choice. If they are willing to be educated, they're going to feel much better about the choices they make.
Yes. Well, if they're unwilling to be educated on it, well, then, hey, we've got two options. It's either going to be a higher upfront cost or it's going to be a greater risk. One of the two. Because either you can pick this out and understand what happens if we're wrong when we make this choice and be okay with it, or you can pay me and then I'll start accepting some responsibility, because then you're allowing me to do some things that I need to do.
Yeah.
Here's a good question. So, how does modulating equipment affect the suggestion of a full comfort consult? Well, so everybody here, we're offering inverter, full variable speed equipment, whether it's a comfort consult or if it's a free quote. Now, what we've kind of found is with some education, homeowners are understanding the benefits of, modulating equipment to where it's like, okay, hey, our tolerance for getting this perfectly nailed down is greater with better equipment, because single stage, I mean, you really want to size single stage aggressively if you want to control the humidity for most of the year, especially in my climate. If
It's
you
the right,
have, yeah,
it's the right size only under one condition.
exactly, yes. If you go with, like a green speed, which the Bryant 284 or a 5-stage 288, well, then you're gaining such good humidity control. Plus, I mean, on the low sizes, you have a 2 and a 3 ton. And the difference between those is what? 3,000, 4,000 BTUs on the low end. So, really, at the end of the day, most houses are going to be a 3 ton if you're getting that equipment, unless it's a really small house, and then you're going to go 2 ton. So, your choices in equipment's kind of slim there. But if you're willing to pay for the equipment, I mean, you've been to enough houses to go, oh, that's a 2,500 square foot house. That's the same typical one I've seen that I've put a 3 ton in every single one I've done. That's been a good house. Well, I would feel really good if it was my house and I'm the one making the decision. I mean, I put my equipment in at my house and I didn't even do a load calculation beforehand. And that's just because, when you've looked at it and that, okay, a good house, here's where you're going to fall. Well, I'm just going to go, oh, I'm going to size it to a good house. And if my house isn't good, I'm going to fix it. So again, it's just kind of reiterating that, recognizing you have other levers. And so the actual equipment itself, it modifies the suggestion in a way of going, hey, if you're actually looking to have a comfortable house, if you're trying to get really good humidity control, really good load matching, really good air mixing, you have to have some level of this inverter equipment. And if they go single stage, you're responsibly avoiding responsibility by going, hey, here's the downfalls to single stage. Here's what you should expect. And so it's just putting into perspective of what the different levels of equipment can offer, and gives you an opportunity to have the discussion of, okay, is that a problem? If we put in this single stage unit and you look like this unhappy face down here when it comes to humidity control, is that going to be okay? And if it's not going to be okay, well, then what do we need to do about that?
Put that graphic up, Tanner.
Yeah, I need to, let me grab that.
Faces.
Yeah, I should have had that ready. I kind of slapped this together kind of last minute.
Well, the faces are frowny face, bland face, happy face, essentially ranging in there for the features that are offered with the package. Single stage equipment does not have, only has good humidity control at design conditions. It doesn't have good air mixing unless you're fine having your fan running at high speed all the time. Filtration, if they're not buying good equipment, they're not likely to buy a good filter. So if you're able to find that, Tanner, there you go. So there we have a range of, now you're on hybrid. Oh, okay. That one's backwards. I'm seeing the.
Yeah, this was just this. It's a little out of whack. I didn't have a fixed template.
That's okay. So
ready on hand.
The red faces and orange faces are poor performing. And the green smiley faces are the better performing. There's variable, hybrid, or basic. Let's just look at those two. So single stage equipment. Oh, now that's size. Sorry, I'm having to lean forward and squint on my
Yeah, they're all 63 tons.
okay.
It's very bothersome that you
There we
have
are.
the
Down at the
hybrid
bottom.
with the verbiage AC in there.
Yeah, this was one of the pre-made templates that
that
popped up on my
Yeah.
one of my well, just one that I had saved. So this was not a good.
There we are.
I'm
I've
just teasing.
I've never put this one in.
I've found the things. There we go. Load matching. Third from the bottom. Variable speed will give you load matching. And scrolling over to the right with the frowny face, basic does not give you load matching. It's
Yes.
right at one temperature only.
Yes.
Same for dehumidification, same for air mixing. Those are the three which are readily understandable by the customers. Filtration is shown on that one. So that's where comfort comes in. You can get a temperature, but temperature alone is not comfort.
Yep.
In most cases, I'm not doing a 1-inch filter ever, but that's just me. But
yeah,
yeah,
I do it as if someone is asking for just the cheapest thing possible,
bottom price.
and I'm just like, okay, well, I'm gonna we could do a stripped down version, and we're basically gonna, cut all corners that are, within reason, and you get no warranty.
Yeah.
Like reusing disconnects and stuff.
Yeah.
Yeah. You don't get a thermostat. You get 2 wires on the wall to touch.
You get a light
You get one of those
switch.
temp stats like in new construction.
Yeah.
Yeah, the 70 degrees thermistor.
Yeah.
All right. Well, I think we've even gone over our expected hour.
Yeah.
Covered a lot of stuff.
Yeah, we crammed a lot of stuff in hour and 15 minutes. So,
Ronnie, any other comments?
I think you've covered about everything.
Okay.
Yeah, it was very
I've just been
impromptu. So,
listening.
Yeah.
I've been doing a lot of listening today.
Well, thanks for coming, everybody.
Yeah. Thank you, everybody, and we will catch you all on the next one.
Okay.